All right, so we talked about it yesterday, but I want to make that note for you guys as well. Jot it down. Okay, standard or stock solution. It's your known. They all mean the same thing. Standard, stock, known, they all mean the same thing. They may be referred to in different ways. You guys have to know that they're all the same. Basically, guys, if you have a molarity and a volume for a solution, whether it's an acid or a base, that's your stock solution. You know the volume and you know the molarity. You're going to be searching or calculating for the other molarity or volume, depending on what they give you, but one of the other pieces of the other substance. Okay? So we did this example yesterday. You can again go back and watch that video. Let's move on to example number 2. So it says if it takes 25 mils of 0.20 molar H2SO4, what's the name of H2SO4? Sulfuric acid. To neutralize 37 mils of NaOH, what is the molarity of the NaOH? So, which is my stock solution here? It doesn't say standard or stock, but you have to identify which one it is. Why is it H2SO4? Why is it the acid in this case? Because we have both pieces, guys. This, again, why I've tried to train you all year long to jot down your variables. This is why. All right, so molarity of our acid. Do I have that? You bet. 0.20 moles per liter. What's the volume of my acid? So, Sam, you said 0.025 liters. Is that what was given to us? No, what was given to us was 25 mils, but again, that's the habit, folks. As soon as you see milliliters, you've got to convert that to liters because we're dealing with concentration here. By definition, it's moles per liter. We have to be in our liter unit. So, as Sam said, 0.025 liters. All right? Is that the same number of sig figs in both of those numbers? Absolutely. Now, the base. What are we given about the base? Volume. Okay, 37 mils. What do we need to do with that? Change it to liters, which is going to be what? 0.037 liters. Do I know the molarity? No, I do not. Okay, so that's what I'm looking for. All right, so have I really done any of my steps to figure out or do the calculations for titration? No, all I've written down, guys, is my given information. What was given to me in the problem. What's step 1? Write the balanced equation. Go ahead and do so. So what type of reaction is this? It is a double replacement, okay? They're all going to be, but be more specific then. It's a neutralization, guys. So what is always produced in any neutralization reaction? Water and salt. So you know that water is one of your products, and the salt, what is a salt in general? It's an ionic compound. Any ionic compound, guys. So you know you're going to have water plus some other ionic compound that's present. So we've got sulfuric acid plus sodium hydroxide. All right, is going to yield, and I'm just doing it because of the way it's written right there, so I don't, so I have more space over on the right-hand side. So we know that water is going to be one of the substances plus my salt here is going to be what? What's the formula going to be? It is an acid. What acid? It's not an acid, I'm sorry. It's going to be Na. Why is it Na2SO4? You have to go back and use the crisscross method, folks. You cannot forget to do that. New compounds, you have to go back and look at them, especially ionic compounds. Right? Molecular ones are the only ones we don't use the crisscross method for. Am I done with my equation? No, I predicted my product. So every equation has what pieces in it? States of matter. And how do I know my states of matter? Where do I look? Solubility rules. Now water is going to be what? Liquid. Okay, so we've got to go back, and now if you start with an acid and a base, guys, what are their states of matter going to be always? Aqueous, okay? It's the nature of an acid and a base. They're aqueous solutions, but we've got to check that salt. Well, really, guys, if you think about it, the term salt means ionic. It's going to be group 1 or 2 element. You're never going to see with a titration a transition metal in there. So all group 1 and group 2 salts are what? They're soluble. All right, they're aqueous. So aqueous solutions with what it's going to be. All right, am I done with my reaction? No, why not, Gabby? We got to balance it. How do we balance it, folks? Again, with these neutralization reactions, I highly recommend that you write water as HOH so that you can see the hydroxide ion in there. It's going to make it easier for you to balance. Okay, it's going to make it easier to balance that way. A lot of people may look at it and be like, oh, I just need, my hydrogens are balanced, so I've got 2 on each side, but then you're forgetting about hydroxide. All right? Excuse me, to balance this out, we have to have a 2 right here and a 2 right there. All right, so it should be, the way I have it written, 1, 2, 1, 2. Okay? Questions on that reaction? We should be able to do that by now. If you're struggling, come see me after school today. I'm here for tutoring. I'm available to ask questions. All right, so there's step 1, write a balanced equation. What is step 2 in this titration process? Mole ratio? No. What's step 2? Go back and look at your notes, guys. That's why you have them. You're not going to have your notes. You have to know this process. What is step 2? Read. Yeah, the moles of your standard solution, okay? So we have molarity and we have volume. Can we use those two pieces to figure out the number of moles? Absolutely, because our molarity formula is molarity equals moles per liter. So how do I get moles by itself? Multiply each side by liters. So that's going to be N equals molarity times volume, all right, which again is V, or in liters, excuse me. So when we plug it in, we get our molarity is 0.20. Oops, did not write that right. 20 moles per liter times our volume of 0.025 liters. Guys, if you haven't noticed yet, this is only our second problem, your number of moles that you have for each solution are very tiny. All right, if you get a giant number for moles, you've done something wrong. Okay, we're dealing with tiny, tiny numbers here. Go ahead and do that. 0.2 times 0.025. Might be mental math for you. When you plug that into your calculator, what do you get? Yeah, 0.005. And that's your number of moles. I'm done, right? I'm done? No, it's only halfway there. So we figured out the number of moles of our standard solution, guys. So again, what is the point we're trying to get to in a titration? It's called something point. Equivalence point. And what is that equivalence point? What does that mean for us? It's not that the pHs are equal. The concentration of what? H plus and OH minus, guys. So why we are calculating this titration example data that we are given, they have performed a titration. They have said when they get to the equivalence point, it's 25 mils of sulfuric acid is used to neutralize 37 mils of NaOH. Okay? That's at the equivalence point. That's why we figure out the number of moles of our acid. And then we go and use some stoichiometry, the mole ratio, to figure out the moles of our base, or our unknown. Okay? Because we're at the equivalence point. It's where hydroxide and hydrogen ions are equal to each other. Alright? That's the point we're looking for. It doesn't have anything really to do with pH. I mean, they're related to pH and pOH, but those don't have to be equal. It's when those concentrations are equal to one another. Alright, so there's step 1 and 2. Balanced equation, figure out the moles of my stock solution. Step 3 is what? Figure out the moles of the unknown. And what are we going to use to figure out the moles of the unknown? The mole ratio, guys. So, we're always going to be looking at the acid and the base. What's the mole ratio between those two? It's a 2-to-1 mole ratio, folks. Okay, 2-to-1. It doesn't matter really how it is. Your units will be set up. So in this box for mole ratio, I want to see you write it out. 2 moles of NaOH for every 1 mole of H2SO4. So where it shows mole ratio in that box, put your substances with it so that it doesn't confuse you. Which one's on the top of the fraction and the bottom will be determined by what you're starting with. Okay? When we get to stoichiometry. So now it's just going from given to unknown. It's a mole-to-mole problem. Alright, so we're starting with 0.005 moles of H2SO4. The acid was our stock solution here. Alright, and then we are going to have moles of H2SO4 on the bottom. And we're going to have moles of NaOH on the top. So since we wrote our mole ratio out, All right, it's easy. Just match it up. 2 moles of NaOH on the top, 1 on the bottom. 0.005 times 2 is what? 0.01. 0.01 moles of NaOH. Am I done now? No, because what am I looking for? The molarity, guys. Now this should be the easy step. We've done this a lot. My molarity formula, capital M equals N over L. My moles, we just said, was 0.01 moles over my liters. How many liters of NaOH do I have? 0.037 liters. So then I can go up here and just write in my molarity. Go ahead and do the calculation. So our molarity here is 0.27 moles. All right. That's our molarity. That's our concentration. Now, there's a lot going on, guys. A lot of pieces. You got to take it step by step. If you skip steps, that's where you're going to get confused. Start with your balanced equation. Get the number of moles of your stock. Mole ratio. You go from mole to mole, given unknown, and then get your volume or your molarity. All right, I want you guys to try the U-try problem that's in your notes. All right, try the U-try problem. I'm going to kind of explain it as I go along. So step 1 again, write down your information. We have 32 mils of barium hydroxide, so that's going to be 0.032 liters. Is added to 10 mils of nitric acid, so our acid data, we have 0.0100 liters of acid. The molarity of the barium hydroxide is, so guys, which is our stock solution here? What's our standard solution? Barium hydroxide, because we have both pieces, 0.20 moles per liter. We are looking for the molarity or the concentration of our acid. So the first thing I need is my balanced equation. So I've got barium hydroxide plus nitric acid. They are both aqueous. All right, and then we're going to produce water and a salt. My salt here, folks, should look like this. It's barium nitrate. Barium has got a 2+ charge. Nitrate has a 1- charge. So it's BaNO3 2. All nitrates are soluble. All right. There's my balanced equation. My next step is to do what? What's after balanced equation? No, I said after the balanced equation, what's our next step? All right, so we got to figure out the moles of our stock. Our base is our stock. Folks, I'm not going to show how to get moles by itself from molarity. We do have to balance the equation. All right. So to balance it, we should have a 2 in front of nitric acid and a 2 in front of water. Okay, so now moles of our stock solution, N equals molarity times volume. So that's going to be our molarity of 0.20 moles per liter times our volume of 0.032 liters. Liters will cancel out. Number of moles I have would be what? 0.0064, right? Go to like 2 or 3 non-zero decimals. Never round, folks, in this stage. If you round too soon, everything else is going to be messed up. So we've got our balanced equation. We have our moles of our stock. So now we're going to look at that mole ratio. So our mole ratio here, guys, is going to be 2 moles of HNO3 to 1 mole of barium hydroxide. Okay. So we're going to go from moles to moles. So we've got moles of barium hydroxide, 0.0064 moles of BaOH2. All right, moles of that on the bottom will cancel out. And on the top, we have moles of nitric acid. So it's a 2-to-1 ratio, so we're multiplying it by 2. Okay? So you might be thinking, maybe some of you did, maybe you didn't, Well, when we were doing concentrations with pH and POH, we identified if we have an acid or base, we had to look at the number of hydroxides or number of hydrogens. Have we done that at all here, guys, with concentration? No. Why not? This is why. Because we're looking at the mole ratio anyway, guys. We didn't call it or looking at the mole ratio before when we were doing just basic pH and POH calculations. Where to get the hydrogen ion or hydroxide ion, you had to multiply that value by however many you had. We were using the mole ratio without even realizing it. Here, since we have this step to do our mole conversion from given to unknown, we're taking care of that in this step. So you don't have to worry about it with titrations of, oh, well, I've got an acid that's a diprotic acid, I've got to multiply my constant. No, you don't have to do that because the mole ratio takes care of that step for you. So here, when we do this, we get 0.00. I'm sorry, no. It would be 128, correct? Moles of barium hydroxide. Nope, I can't speak today. HNO3. Questions so far? All right. Now the last step is do molarity. I'm going to do it up here, guys, just to give myself some more space. Moles per volume, which is moles per liter. So we have 0.0128 moles over how many liters? All right, just like that. Okay. When we do the math, what is the molarity that we end up with? 0.128 molarity, guys, molar or moles per liter. All right, that's how we go about that process. Questions on any step here in this problem? All right, I was just listening to you guys. It's 1.28. My apologies there. 1.28 because you had 2 decimals, a hundredth. Okay, so this is the extra problem. You have a blank box chart, guys, in your notes. This is the problem that I want you guys to solve. Go ahead and try it on your own. All right, folks, so when you take a look at this problem, step 1 is to write your balanced equation. This is what it should look like. You have to have states of matter, guys. If you don't have the states of matter, you're going to lose a point. If it's not balanced, you're going to lose a point as well. Okay, so from here on out, like I said, the rest of the school year, you have to have your states of matter. Otherwise, you're going to lose points because it's not a proper reaction. So, jot down what we have. We have 1.5 moles per liter of NaOH. We have 20 mils of nitric acid, which we're going to change that to liters, 0.0200 liters. We also have the molarity for nitric acid, which is 2.5 moles per liter. So which one is my acid or my base, my stock solution? Why is the acid the stock solution? Because you have both the concentration and the volume. So that's the one we're going to use to figure out the number of moles. So again, molarity equals N times V. To get N by itself, we multiply by V on both sides. So N equals molarity times volume. So here we go. It's going to be, in this case, 2.5 moles per liter times 0.0200 liters. So my molarity then, my moles, 2.5 times 0.02, what did you guys get? Louder. 0.05 on the dot. All right. And that's going to be moles. Now, is that correct with sig figs there? That number is only 1 sig figs, but how many should we have? 3. Okay, now technically, 3 is based on our volume, but 2 is for our molarity, guys, and that's what we look at. Remember, least number of sig figs, so we should put out a 0 there, all right, like this. We're going to end up with 2 sig figs in the end. Now, right now, guys, it didn't matter if we had it or not. We could do that at the end, but as far as rounding goes early on, remember, you don't want to round until the very, very end of the problem. Now, whether you had the 0.05 there or you wait until the end, guys, it doesn't matter, like I said, because it was an even number. So we're not worried about how we round here. Round it at the very, very end of the problem. Okay, so we've got our number of moles. Now we're going to use our what? Mole ratio. So this, in this case, guys, is a 1-to-1 ratio. All right, so it's going to be a little bit easier with that math. So here we go. We got 0.050 moles of nitric acid, HNO3, over 1. Moles of HNO3 on the bottom. Moles of NaOH on the top. Okay, so 1-to-1. That math is super easy. 0.050 moles of sodium hydroxide. Okay? Last step then is to figure out, oh wait, is this the same problem that we've seen? What are we looking for here, folks? We're looking for volume, not molarity. So you can't just take it in and plug in moles per liter. Here we got to do one extra step. Molarity equals moles per volume. We are looking for volume. How do we get volume by itself? Multiply by V on both sides. That cancels out there. So then our new equation, guys, is N equals V times molarity. That doesn't do anything for us. We want volume by itself. So now we're going to, divide by molarity. So V equals N over molarity. Now we can plug it in. 0.050 moles over a molarity of 1.5. We will be left with liters in the end, because this is moles per over liters. So liters comes up on the top. What is our final volume? When you take 0.05 divided by 1.5, what do we get? 0.0 what? 33, right? Because 2 sig figs is what we said. And what's my unit going to be? Liters. So folks, now you've seen a problem where you can solve for the molarity. We've done 3 or 4 examples like that where we're solving for molarity. But we can also solve for how much, which is volume related. Questions?